So the first thing we're going to do is just quickly review exponents. We use them all the time in physics. You'll find out that we use them in our problems, and we also use them in our units, like kilometers, centimeters. They all involve exponents. So we're going to use exponents all the time. So to refresh your memory, the exponent, or the number 3 raised to the exponent 2, 3 to the power of 2. What it means mathematically is we take that bottom number 3 and we multiply it by itself 2 times. This does not mean 3 times 2, it means 3 times 3. You're multiplying this times itself as many times as is specified in the exponent. So as you know, 3 times 3 is 9. So that's what the answer is to 3 squared, it's 9. Now what if you had the number 2 raised to the power of 3? Well, what that means is you take the bottom number, multiply it by itself how many times? Well, you do it as many times as the exponent says. So 2 times 2 is 4, 4 times 2 is 8. So 2 to the power of 3 equals 8. Now the rest of these examples, I'm all going to, the concept of an exponent can apply to any number. I can take 147 and I can raise it to the power of 4. Like 147 to the power of 4, that would be 147 times 147 times 147 times 147. I've done it 4 times because I took 147, I raised it to the power of 4. But in reality, you don't do that too much in physics. We use exponents for some things, but usually you're not doing that kind of thing too much with large numbers. But we do use powers of 10 all the time. So exponents can be applied to any number. We can use it for anything. But we have a special relationship with the powers of 10, and you'll see why as we get a little farther in the class. But if I take the number 10 and I raise it to the power of 1, what does that mean? Well, that means I take the bottom number and I multiply it by itself. Well, it's a little bit confusing because when I say multiply it by itself, you think I'm going to multiply again by 10. But what I'm trying to say is look at the pattern here. We wrote down 2 3s and multiplied them. Here we wrote down 3 2s and multiplied them. But here there's only 1, so really it's just 10. We don't write anything else down because it's already there one time. So 10 to the power of 1 is 10. 10 to the power of 2, that's going to be 10 times itself. So 10 times 10, that's going to be 100, right? 10 to the power of 3, you're going to see these types of exponents all the time. It is what? Take the bottom number 10 times itself again, 3 times, again because of the exponent. 10 times 10 is 100, times 10 again makes it 1,000. 1,000. Now, these are larger and larger powers, so as I get higher and higher, notice what's happening. I went from 10 to 100 to 1,000. So every time I increase the exponent, I increased times 10 every time. That makes sense because I'm multiplying by 10 each time I go down the list. But here's the thing that blows your mind, or blows a lot of people's mind. You can actually have exponents that aren't positive numbers here. They're actually negative numbers here. All right, so if I have 10 to the power of -1, what do you think that means? Well, first you're like, well, how can I multiply 10 times like itself -1 times? That doesn't make a lot of sense. But if you remember back to algebra, when you have a negative exponent, what it means is you put the thing here on the bottom, move them downstairs, and make the power positive. So negative exponents in math are defined literally to mean you move them to the bottom of the fraction and make the exponent now positive. Now see, because you know that 10 to the 1 is 10, this is just 1/10. And if you know, you can put that in your calculator or you could divide it by hand. 1/10 is just 0.1. All right? Let me get a little farther and I'll draw some comparisons to what we have on the board. So that's 10 to the -1. What if we had 10 to the -2? Well, since that's a negative exponent, what it means is you move it downstairs and make the exponent positive. So it's 1 over 10 squared. But you know what 10 squared is. It's just 100. We wrote it down right here. 10 squared is 100, so on the bottom is 100. Now what happens if you take 1 and divide by 100 in a calculator or by hand? You get 0.01. So notice what's happening. As I go more into the negative territory of the exponents, the answer gets smaller. Let's do one more to draw the final kind of conclusion here. 10 to the -3. That's going to be 1 over 10 to the power of +3. Move them downstairs, which is 1 over, what is 10 cubed? It's written right here, it's 1,000. And if you go in your calculator and divide 1 by 1,000 or do it by hand, you're going to get 0.001. So I want you to understand the pattern, and the reason why I'm harping on it is because in a couple of lessons I'm going to teach you about the metric system, which is all about powers of 10, and that's how we define kilometers, millimeters, centimeters, megameters, you know, all that stuff, all those prefixes. They're all related to the powers of 10. They're ways to make the units bigger or smaller by a multiple of 10. So I want to show you what this means, and that's why it's important. So here's the pattern. If you go bigger and bigger and bigger in the positive exponents, the number gets bigger and bigger. If you go deeper, deeper negative, but larger values in the negative sense, the numbers get smaller, smaller, smaller. So if I have 10 to the negative 10, let's say, that's going to be a decimal point with a whole lot of zeros and a 1 at the end there, much like a power to a very positive, like 10 to the positive power of 10 is going to be 10 zeros in that direction. So as you get more and more negative in the negative exponents, your numbers get smaller and smaller. And as you get positive higher in the positive exponents, the numbers get very bigger and bigger. That's what it basically means. But notice that each time I go smaller, smaller, or bigger in the negative exponents, I just insert another decimal here. So what it's doing is it's like I'm moving the decimal point, basically. If you kind of look at the pattern as a whole, if you come here, if I move from here to here, I've moved the decimal. There's a decimal point here. I move it over and I get 100. To move from this one to the next one, I move the decimal point over and I get 1,000. Here, to go from here to here, I move the decimal point this direction to the left because it's a negative exponent, giving me 0.01. And to go from here to here, I move the decimal point again to the left, giving me 0.001. So the concept here is on exponents. We're going to get to units later, but just keep in mind that they're related to one another. And that's why I'm bringing it up. Now I want to talk about the concept of equations. Probably one of the most important things you learn in algebra, and we're going to learn how to solve, we're going to review how to solve simple equations here. X plus 2 is equal to 10. What it means is we need to figure out for ourselves what value of x must be true to, when you add number 2 to it, you get 10. Now I know you know the answer is 8 because 8 plus 2 is 10, but in algebra we don't guess and try to figure it out by guessing. We have rules. And the rule is you want x to be on one side of the equal sign. It's like a game of checkers or a game of shells or something. The goal is keep x on one side of the equal, move everything else to the other side. And once you have everything else to the other side, then you know what x is, because x equals whatever it is. So here the goal is this 2 is hanging out with the x. We don't like that. We want to move them to the other side. So when you first start algebra, you do things like you'll subtract 2, you'll write it down underneath from both sides. We'll subtract from both sides. That gets rid of the 2 on the left because it's 0. And then x will be 10 minus 2 will be 8. And this is the answer. When you get up into the physics level, you're doing the exact same thing, but you're not always writing it down, -2, underneath. Like when you first learn algebra, you write it underneath to kind of keep it neat. But the equations will be a little more complicated in physics. So if you do that for everything, you're gonna probably waste a lot of paper. I do want you to show every step though. So let me show you how I do a problem. We'll choose a slightly more complicated one next. Let's say we have 2x minus 6 is equal to 18. See, this is a little harder to guess what x has to be. So we don't want to guess, we want to do it with rules. So the 2x we're going to deal with later. The first thing is get rid of the 6. How do we get rid of it? We have to do the same thing to both sides. We're going to add 6 to the left to get rid of it. Then that means we'll have to add 6 to the right. So what we're going to do is write the equation again with just moving the 6 over. So the next line under here would be the following. 2x is equal to 18 plus 6. So it's implied that when I move from this step to this one, I've added 6 to the left, getting rid of it, and I've added 6 to the right. You can see it's still here. It's cleaner to write it like this than to do all this business underneath it, because that just gets cumbersome for more complicated equations. So you have 2x is equal to 24. I have a similar thing going on here. I want to get x by itself. So how do I do it? I'm going to divide by 2 on the left. I'll do the opposite of the multiplication here. So I divide by 2. That means I have to divide by 2 on the right. Now, when you're starting algebra, what you'll do is you'll literally write it down, divide by 2, divide by 2. But again, all of these little micro steps clutter up everything. So you get a little more practice, like the point you're at now. What you will then write is the next step will just be x equals 24 over 2. So then x equals 12. See, we've saved all the clutter of not writing it underneath. So here, when you go from this step to this step, you know that you've divided by 2 because that's the only way you can get rid of it. On the right-hand side, I'm still going to show it. So then I have 12. And that's the right answer. And you can always check your work, because if you take the 12 and you stick it back in for x, 2 times 12 is 24. 24 minus 6 is 18, so that's good. That's the solution for that equation. If you don't get the right answer, when you put it back in, you've done something wrong. So these are basic equations. I'm not going to solve a ton more equations because we're going to get lots and lots of practice solving equations in physics. But what I do want to do is show you that you can use these manipulations to move things around in equations, even when they don't involve numbers or anything like this. So for instance, I think you've all heard of the equation E equals mc squared. And you're like, wow, I didn't think we are going to get into E equals mc squared so early. Well, we're not. But what if I want you to do the following? What if I want you to solve, what am I having you solve for? For m. Solve for m. A lot of people will look at this and they'll know how to handle it because it's the algebra problems you've seen over and over again. But this is an equation, just like any equation. And you can do whatever you want to do to this equation as long as you do it to both sides, with the goal, in this case, we want to find m. So how do we get m by himself? How do we do that? Well, if I rewrite the equation, in this case I am going to show all the steps because it's a little bit weird looking. mc squared. So what do? On the right-hand side, I want m by himself, so I'm going to divide by something. What am I going to divide by? I'm going to divide by c squared. It is no problem to divide by something with an exponent, because you can divide by anything. C squared is the speed of light, squared, times itself, in other words, speed of light times itself. So I'm going to divide by that, but when I do it to the right, I have to do it to the left. And so I'm going to get, of course, that's going to cancel, so it's going to drop away. M is going to be by himself. So when I rewrite it, it'll be m is equal to E over c squared. And that's the answer. So the reason I'm showing you this is because in physics, I might give you an equation, or you might have to use an equation that might involve the motion of a baseball. And it'll be a larger equation than the ones we have on the board. But the question may not ask you, how fast is the ball going? In other words, the equation might be written for how fast is the ball going, but you may not want to calculate that. I may ask you, how long is the ball in the air? So you will have to, on your own, grab the time variable and solve the equation for t, which will mean rearranging it, and then using that to find the answer. So you're going to have to manipulate equations pretty much all the time in physics. So this kind of thing of messing around with variables, moving them left, moving them right, is very, very important there. So another example of that kind of deal would be, what if I gave you an equation, v equals 2d plus 3a? What is v? I don't know. I just made this equation up. What is d? What is a? It doesn't matter. D could be the diameter of a tube. A could be acceleration of a golf ball. B could be the velocity of, air molecules or something like that. It doesn't matter. The point is, it's some sort of equation. What if I want you to solve for the variable d? Why would you want to solve for the variable d? Because in my problem, I may give you some information about gas particles and acceleration, a, and I may tell you, find d, the diameter of the tube. So you're going to then know that I need to take and modify this equation and solve for d, right? So you're going to have to do that on yourself. So you follow the rules of algebra. I'm going to deal with the 2d last. I'm going to move the 3a to the other side. So I do that by subtracting both sides by 3a. So on the left, I'll get v minus 3a. On the right, I'm just going to have 2d. To go from this step to this step, I just subtracted 3a from the right, meaning it got rid of it, disappeared, because it subtracts to 0. But when I do that, I must then subtract from on the right. So it would be v minus 3a. I subtract 3a from both sides. Now the next thing I need to do is I want d by himself, so I'm going to divide by 2. So what I'm going to have on the left is v minus 3a. The whole thing gets divided by 2 because it's the whole quantity divided by 2. On the right, it's going to be d. Because I divide by 2 on the right, that cancels. 2 divided by 2 gives me 1. I divide this again by 2. Same thing on both sides there. So then in my equation, I would be using v minus 3a over 2. So if my question was, this equation is solving for velocity of whatever, but I don't want to ask you that in the problem, I'm asking you for this, then you now know that you can rearrange these things to get after what you need to get after to solve that problem. That's probably one of the biggest things that trip a lot of people up, is that the problems are not going to be set up in a way that's just going to tell you multiply two numbers together and get them. You're going to need to grab the equation, move it around yourself, to find what you need and then to solve the problem using that. And so you have to be comfortable with those rules of algebra. Okay? Now the last thing we're going to talk about is just a little bit of very basic graphing. We're going to talk about what a graph is, plotting points and things like that. This is all from Algebra 1, Algebra 2. So what if I want to graph the equation y is equal to 2x plus 1? All right. You might also see that written as f of x, which is just means a function of x, 2x plus 1. This is just a different notation than this form. This is what you learn in algebra. This is what you learn a little bit later in algebra, and you also use it in calculus. But pretty much f of x just means y. That's all it means. It means you stick a number in for x, you calculate it, and out comes the corresponding number for y. So how do we graph it, right? So let's first handle it by setting up a table of values. We're going to plug in values for x, and then once we plug those values in, we're going to calculate the corresponding values for y. That's all we're going to do. Now we have to choose some values for x, and you're kind of free to do kind of whatever you want. But usually I just choose a couple of numbers around the origin, around 0. So I usually choose, these are 5 numbers centered around 0, some positive numbers, some negative numbers. That usually will give you enough points to draw whatever it is. So on the right-hand side, we're going to plug in for each of these values. So here we have y is equal to, we stick a -2 in for x, just like that. Now here's where it comes down. In the last section I told you we're going to be multiplying, dividing negative numbers all the time. Well, this is it. This is where it hits you. If you don't know how to multiply these negative and positive numbers, you cannot solve anything. So now we've reviewed that, you should know that 2 times 2 gives you 4, and because it's negative times positive, that's going to be -4. So it'll be -4, but I still have to add my 1. And here, again, same thing. Now I have to add 2 things that are different, and I know from my rules that -4 plus 1 is -3. How do I know that? Because it's a different sign. So I subtract the numbers giving me 3. The sign goes with the bigger absolute value, which is negative. So that's -3. Now I plug in the next value, -1. So it's going to be 2, -1, plus 1. We'll go a little bit faster since you should kind of know this now. 2 times -1 is going to give me -2 plus 1. And when I add these together, I'm going to get -1. I plug in the value of 0. 2 times 0 plus 1. Of course, this gives me 0 plus 1, so I can just put the number 1 down for that one. And then I put the number 1 in here. 2 times 1 plus 1. Now I know that that's 2 plus 1 gives me 3. And then finally this one. 2 times 2 plus 1. 2 times 2 is 4 plus 1 is 5. So here's what I have. I have a bunch of points. Now this is x comma y. So this point is -2 comma -3. This point is -1 for x, -1 for y. This one is 0 comma 1. This one is 1 comma 3. This one's 2 comma 5. The purpose of all this table was just to get the points. And now I can actually do the quick graph here. So what I'm going to have is 1, 2, 3, 4, 5. This would be -1, -2, -3, -4, -5. Of course, you all know this is x and this is y. That's what we learned from algebra. And then I'll do the same thing. 1, 2, 3, 4, 5. I'll label this 5, -1, -2, -3, -4, -5. This would be labeled -5. All right, so let's plot some points. -2, comma -3. This is -2 for x, -1, -2, -3 is somewhere right around here. Next point, -1, -1. It's -1 for x, -1 for y, somewhere right around here. 0, comma 1. 0 for x, but 1 for y means I'm right here on top of the line here. 1, comma 3. 1 for x, 1, 2, 3 for y means I'm right here. And then 2, comma 5. Here's 1, 2, 1, 2, 3, 4, 5 means I'm right here. And as far as I can tell, that is a pretty straight line. I know it's not exact, but you get the idea. It's a pretty straight line. Now, those of you who are sharp, I shouldn't say it like that. Everybody watching this is sharp, here, but some of us have more practice than others, I guess is what I'm trying to say. Those of you who have studied this recently, you would look at this equation and realize this is the equation of a line because all lines have a similar form. And that form here, we can just read it right out of the equation. The slope of the line here, you could just read it right off the equation, was 2, and the y-intercept which we call b, is equal to 1. So when we go back in your algebra brain and realize what that means, it means this line crosses the y-axis at 1, y is equal to 1, which is why it crossed right here. And the slope was 2. That means you go up 2 and over 1, because if the slope is 2, it's 2 over 1. So it's rise, whoops, not 2 over 2, 2 over 1. Rise over run. So that means from my y-intercept, I go up 2 over 1, up 2 over 1, up 2 over 1, and then I could just draw my line like this. But I wanted to calculate everything out to show you how to make a table and also give you a little practice and also show you that what you get with a table is exactly the same thing you get if you just grabbed the information out of there and plotted it. We're going to do one more real quick. I promise it won't be a line. We are going to deal with these kinds of curves all the time in physics. So let's take a look at y is equal to x squared minus 2. How do we plot this? Well, let's do the same thing. Let's first say we're going to make a table of x values and corresponding y values, x squared minus 2. And I'm going to choose the same exact numbers for my x values that I'm going to plug in, -2, -1, 0, 1, 2. So I don't really need the rest of the table. I'll erase that. And I'm going to stick a -2 in here. So y is going to be, I have to open parentheses because when I square this guy, the -2 as a quantity is squared. So if I accidentally wrote it without the parentheses like this, you would be confused. You wouldn't know if I meant that -2 times -2 is happening, or if you square the 2 and then put a negative at the end. You would be confused because it wouldn't be clear. So since it's -2 goes in and gets squared, you have to write it with parentheses. And so what you will have, -2 times -2, which is what happens when we square it, is +4 minus 2 gives us 2. All right. We stick the -1 in, we get -1 squared minus 2. What is -1 times -1? It's +1. +1 minus 2. Again, we have to subtract things that are, you start at 1, you go backwards to the left 2, or you can think of it as addition. You're going to get -1 for the answer here. You could also think of this as 1 plus a -2 and use the same rules from before to get there. 0 will be 0 squared minus 2. 0 squared means 0 times 0 gives you 0, minus 2 gives you -2. And then you put a 1 here, 1 squared minus 2. 1 times 1 is 1, so it's 1 minus 2. And you subtract this, you'll get -1. And then 2. We'll be stick this guy in here, 2 squared minus 2. So you'll get 2 times 2 is 4, minus 2 is 2. And now we can draw our graph. So let's go and draw here y-axis, x-axis, like this. And just to make it 100% clear, this first line forms a point, -2, 2. The next line is -1, 1. Next line is 0, -2. Whoops. 0, -2. The next one is 1, -1. The next one is 2, 2. So let me draw some tick marks. I forgot to do that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. Negative, 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 all the way to -5. So that's -5, -5, 5, like this. Okay? Now, what do we do next? We have the first point, -2, 2. -2 means -2 to the left, +2 up. That means there's a point right there. Next point, -1, 1 means we go to left, -1 up. And you see right here, you realize that I'm human too. What happened was in the second line, we calculate everything correctly, but when I wrote it down, notice that this says -1. I actually didn't carry it through. So hopefully that kind of thing doesn't happen too much, but it does happen occasionally. Rather than just erase everything, I want you to see that I'm a human being also. So the second one is -1, -1. So that means we go left to -1, down to -1. Then we have 0, -2 means we stay on the axis here, but we go down to -2 for y. And then we have +1 to the right, -1 down, which means we're right around here. And then this is 2, 2, which means over 2, up 2, which is somewhere around here. Now this is not exact. I mean, this is a freehand drawing, but you can kind of see what's happening. This thing kind of starts up here, and then it goes and reaches a negative minimum right there and kind of goes like this. So here are the points here. So this is not a line, is the point. It's not a line. Anytime you have an equation that looks like some number times x plus a number, right? mx plus b is what we call it. That's always a line. Anytime you have an equation with an x squared in it, it's always going to look like this parabola is what we call it. So this is called a parabola, right? Parabola. And you're going to work with them all the time in physics because, think about it, when you take a baseball and you throw it at an angle, it goes up, it reaches some maximum, and it comes down. So when we throw things, they form upside down parabolas, basically upside down because they reach a maximum and then they come down. So the equations that govern what a baseball is going to do is going to have a similar form. It's not going to be exactly that, but it'll have a similar form to that. So kind of keep that in the back of your mind when we do those kinds of problems. They should have parabola, x squared type terms. So what we've done in this lesson is we reviewed exponents, super critical. We've reviewed solving basic equations, and we've reviewed basic graphing. If anything in this lesson seems not 100% clear, or you're not sure, or like, I don't get what he's saying, it just means that you're rusty on your algebra. So go back to my algebra class and review these materials there, because physics is not hard, but if you don't know this stuff, then it would be kind of like never ever learning French, but then going to France and trying to live there. And you're just not going to be able to speak to anybody because you won't know anything. So we get these skills up to date and good, and then we go and learn some physics. The next lesson, I'm going to review some core trigonometry that we have to know to solve any physics problems. And then once we do that, we'll start getting into the actual physics topics. Learn anything at mathandscience.com.